Hello, math magicians. On this beautiful day, we are going to find the inverse of a matrix. So, by way of review, let's find the determinant of this matrix. So go ahead and pause, and then come back and check how we did this. So, number one, remember what we're doing with a determinant is we multiply those, we multiply these, and then we subtract the first and the second. So essentially, it's going to be 21 minus a negative 8. So here we get 29. Now let's double check that with our calculator. So come on over to your calculator and go into your matrix menu, and we're going to edit. And this one's already a 2 by 2, so we put a 7, a 2, a negative 4, and a 3 in. Now we're going to exit out, go back into the matrix, hit Math, Determinant, go back into the matrix menu, and pull up the A. And here we see we get 29. So that brings us to how to find a matrix inverse. So let's refresh ourselves first. What do we mean? So by way of a refreshing course here, when we are or you are dealing with real numbers, then adding 0 to any number will result in that number. So, for example, down here, if we have some number A and we add 0 to it, then we get A. So that means that 0 is the additive identity. 0 is the additive identity. So that's what we'll write here. It's the additive identity. The same holds true under multiplication. When you multiply any real number by 1, you get that number. Thus, 1 is called the multiplicative identity. So let's see how they are related to each other. So between inverses and identities. So this one here is you have some number A, you multiply by 1, so therefore you get A. So 1 is my multiplicative identity. So what's an inverse? Well, I start with some number. How do I get that other number to get to the identity? The point of an inverse is to create or come up with the identity. So how do I get to 0 from A? Well, the additive inverse is the opposite of A. And notice what it is. Identity, when adding 0, doesn't change anything. But when adding opposites, you get the identity. Add the opposite to get identity. So how do we get, in multiplication, how do I get the identity? If I have some number A and I want to get 1, how do I multiply out? Well, the answer to that is if you multiply by 1 over A, also known as a reciprocal, you get 1. And oftentimes we'll write that as A to the negative 1. So A to the negative 1, or 1 over A, is your multiplicative, is the inverse. This is my inverse because it gives me the identity under multiplication. Matrices have same rules. Matrices have the same rules. So for any square matrix, n by n, the multiplicative identity matrix of this matrix, I, or I sub n, is 1s all along the diagonals. 1s all along the diagonal. So if it's a 2 by 2, this main diagonal there has to all be 1s. The rest of them are 0s. Notice the rest are 0s. The same holds true for a larger matrix. a 3 by 3 there. So all of those down the main diagonal is 1, and the rest of everything else is 0s. So the main diagonal is 1s. Okay, if A and B are square matrices, A times B equals B times A, so you have to have commutative property here that equals I. Then B is the multiplicative inverse matrix, and we can also write that as either B or A to the -1. So the -1 there means inverse. Notice what it does not mean. This does not mean 1 over capital A, right? So I'm not taking a matrix and putting it down below. Okay, this just means inverse. We write it like inverse. In trigonometry, remember when we saw cosine and we said inverse cosine? That does not mean 1 over cosine of whatever number you've got there. Okay, so we already know that the additive identity, and I'll just do a 2 by 2 here, is all zeros, right? Because whenever I add zeros all across the board, nothing changes. So, inverse, additive inverse of some number, so 1, 2, 3, and 4, how do I get the identity here? How do I get 0, 0, 0 all across the board there? Well, when I add these here, I have to essentially just take the opposites, right? The opposites there will get me to all zeros. Okay, so we've already looked at those. Well, what about multiplication? Under multiplication. Well, we've already defined that as here. If I have a 3 by 3 matrix, then this is my multiplicative identity. And so how do I get, if I have some matrix, I multiply it by some other matrix, and I'm going to get the identity. How do I find out what this is right here? We have some A, how do we find this right here? And that's what we're going to look at today. But beforehand, let's determine if we do have multiplicative inverses. So, in order for this to be multiplicative inverse, then A times B has to equal B times A, and both of those are going to give me I, and this is I sub 2. So it has to end up, when we multiply things out, we have to get this matrix, because I have my main diagonal is all 1s, everything else is 0. All right, so I'm going to turn to my wonderful calculator here and show the work in that. So again, I need to go into my matrix menu, and I'm going to edit. Number 1 is a 2 by 2 menu, or excuse me, A is a 2 by 2. So I do a 1, a 2, a 3, and a 4. All right, so let's come back, and we're going to edit this time B, and we're going to turn that into a 2 by 2 matrix. And I'm going to put in my numbers here, a -2, a 1, 3 halves, and -1 half. So -2, 1, 3 halves, and then a -1 divided by 2. Or you could put -0.5 as it does for you. Okay, so now we're going to test this real quick. I'm going to quit, and I need to multiply out A times B. Let's see what I get. Yay! So here we see that we do get the identity matrix. Now I need to commute those. So I'm going to do B times A. And look, because I get those twice, I get the same identity twice, the answer to this one here is that indeed these are inverses, because it works here. All right, so we're going to try this with a larger set. Let's look at part B there. And we're looking at a larger set there. I'm going to enter those in, and then we're just going to plug into our calculator. So let's go ahead and do that. Here, come back to my calculator, go into my matrix, and I'm going to edit, turn it into a 3 by 3, 1, 0, 2, -2, 1, 1, and -1, 1, and 2. Okay, now go back into the matrix here, and I'm going to edit the second one there. And again, make this one a 3 by 3. -1, -2, 2, -3, -4, 5, a 1, and a -1. Always good to double check that these numbers match up, and they do. Okay, so now we can quit. And now, notice here, since I already have stuff entered in my A times B, I'm going to go ahead and just pull that down. And look, I get that exact identity, the ones down the main, and now I'm going to commute that just by selecting up there. Yay, that one does indeed work. So, again, because A times B equals B times A, and in this I get this matrix, it's a check. So the last one here is where we're going to see what happens when we don't get it. So I'm just going to show you this graphic over here, and notice what happens. When we do enter things in, we get the non-identity right here. There's no ones across the diagonal there. So clearly we see this one is not true. So we don't even have to do the second one there in order to see that. So these are not inverses. Okay, so go ahead and take a moment and practice that down there. All right, now how do we find the inverse? Now our calculator can do that very, very quickly. Our calculator, really the inverse is just this button right here. So if I had some random matrix, let me go ahead and choose number 4 there, and that's what my matrix looks like. So notice that if I pull that up and just simply do inverse, it's going to give me the answer right there. So hardly any work. So let me show you how it's done by hand, and so thus how our calculator is doing it. So if it does exist, we can use the determinant to find the inverse of a square matrix. So if you have some A, B, C, D as your matrix here, first off, if the determinant is 0, then there is no inverse, and we call that a singular matrix. Otherwise, then the inverse is written like this. Now it looks a little bit confusing, so let's see what happens here. Notice where, here's D, and now D's in the top left, and here's A, and here's now A. So what did we do with those? Essentially all we're doing is switching places along the main diagonal. Okay, and what about the others here? How does this change to there? And how does this one change here? Well, notice it's just opposites. So notice we are just switching these two positions, and along the minor diagonal we're just taking opposites. Okay, and the second part is it's going to be the reciprocal of whatever the determinant is. So if the determinant is 10, then 1/10 here is going to multiply each of those. Okay, so that's what it is. We're going to find the reciprocal of the determinant and multiply it by this new matrix by flipping and oppositifying and then bringing it all together. So I'm going to show you by hand, even though our calculator does it really, really quickly. So, okay, what do we do? First off, let's determine, does this have an inverse? Does it even have an inverse? So let's find the determinant of A. The determinant of A. Now remember, the determinant of A, we're going to multiply those, so we get -9, and then we're going to subtract the product here, and that's a -6. So clearly we see we have an inverse. Inverse is possible. So here we get a -3. So the answer, first part is, does it have an inverse? The answer is yes, it does. Okay, we haven't figured out what that is yet. So, but we do know that we're going to do this. A to the -1, my inverse, is going to be 1/3, or the -1 over -3, or -1/3. And let's do our little jimmy jig flippy floppy thing with these here. So the main diagonal, switch position, and we take the opposite of the other one. Main diagonal switches, take the opposite of those. And now we just 1/3 just means 1/3 distributes all across. So we end up with negative 1, a positive 2, a negative 1/3, and a positive 1. So there is my inverse. Now let's pause and just double check that with our calculator here. So I'm going to go into the matrix menu and I'm going to edit. I'm just going to choose a different one. Oops. Come back here and we're going to edit, and I'm just going to choose number 5 for no particular reason. It's a 2 by 2, and let me enter in my numbers: a -3, a 6, a -1, and a 3. There we go. So exit out. Now pull up the matrix. We already did that. And coincidentally, and now I just take the inverse there, boom, and look at what we get. We get -1, which is exactly what I got right there, and -1/3 down below, then a 2 in the top right, and a 1 down below. Bing, bing, bang. Good. So it's much faster for you just to do simply this. Just say a to the -1 and plug those into your calculator. You should practice by hand at least one of these at some point, but go ahead and check it with your calculator. All right, pause, take some time to do that. Okay, now let's see what else we have to do. The very last thing I want to do is to show you how inverses can be used to create ciphers and also to decode ciphers. So let's look here. We can use matrices to encode private information and its inverse to undecode, or to decode, excuse me, to unencode. So let's take this fake credit card over here as an example. So I selected some random coding matrix, just this here. It's 2 by 2, should be a square, and 2 by 2s are probably easiest. If you have a 3 by 3, things get way more complicated, although your calculator can do it. So I just randomly chose these numbers, okay? And you can choose 1, 2, 3, 4, you could choose 7s, whatever, or fractions, okay? All right, now, eventually we're going to do multiplication. So remember, we have to multiply. We need to make sure that my matrix that I am making out of these numbers over here, out of the numbers that are here, I need to be able to multiply them. So because this is a 2 by 2, the other matrix there has to be a 2 by whatever. So remember how this works. A 2 by 2 there will give you a 2 by whatever it is when we multiply those out. So here's our digits right there. And all we need to do is take these numbers and we're going to put them into matrix form. So I'm just going to take those and write them across 4, 1, 7, etc., just across the top, and essentially split them in half. So in splitting them in half, I'm going to write this one on the top and this part on the bottom there. Okay, so let's do that. 4, 1, 7, 3, 1, 2, 3, 4. Next line, 9, 8, 7, 6, 1, 3, 5, and 7. You might ask yourself, well, what if we didn't have enough digits here? Like, what if this was an odd? What would we do? Well, you can tag zeros on the front, zeros on the end, or just fill in with ones. It doesn't actually matter. So just as long as you know where your account number is relative to the zeros or to the ones. So now I put that into an appropriate matrix. Now we're going to multiply the coding matrix by the private matrix. So C times A. I'm not going to write it all out here. Rather, I'm just going to go over to my calculator and enter that stuff in. So I'm actually going to use C and A because I already have those. So I'm going to edit the third one here, and I'm going to make it a 2 by 2. So a 5, a 2, a -4, and a 3. So this is my coding matrix. Now let's go back into the matrix, and I'm going to call it edit A there. And this one needs to be a 2 by 8. So 4, 1, 7, 3, 1, 2, 3, 4. Next line is 9, 8, 7, 6, 1, 3, 5, 7. All right, now let's exit out, and we're going to multiply the two together to see what we get. So go into the matrix here, and we're going to do like we showed here. We're going to multiply C times A. C times A to see what we get. So just call up C, which is 3, and then, so we see there, and I forgot to hit multiplication. So come back here, 3 times, and pull up the matrix menu, and A there. And here's what we get. Large numbers, but let's we'll be able to scroll over and see that in just a moment. So here are my account numbers, right? So I end up with this, and I'm going to write it out here. So 38. Give me a second here. 38, 21, 49, 27, 7. I can't see the rest of the screen right now, so I'll have to shift it over in just a moment. And 16, 25, 34, and 1, 3, and 5. Okay, so this is the coded account. It's these numbers right here, the 4, 1, 7, 3, etc., has now become, and I won't write it all out because it's going to take a while, 38, 21, 49, 27, 7, 16, 25, 34, ... all the way to the 5 there. So it's quite large. That has now been encoded, and it looks nothing like the 4, 1, 7, 3, 1, 2, 3, 4, etc. So this account number is just massively changed. Okay, so now what? Now it's encoded. So if I pass this on, if you email someone, they say, "What's your account number?" and you email them this, oh great, they won't get it. Not unless they have the inverse, the way to break it. So let's go ahead and take this in my calculator. So let me show you the calculator here. Notice we already have this one stored, right? So we already have this here. What's nice is, if you haven't seen this button right here before, see the store button, STO? So I'm going to store this answer into a matrix. So I'm going to choose B, because I haven't used that one yet. Okay, so now this whole matrix is called B. So how do we undo it? Well, to undo this, we have to do C to the -1 times B. Now, I don't even need to know what the inverse of C is, because all I have to do is call that up. So let me call that up, the matrix, and I'm going to call up C, do the inverse, and we multiply that by the matrix B. So when you hit enter, you get 4, 1, 7, 3, 1, 2, 3, 4. Boom, exactly as we expected. So the inverse here helps us to find out what our account number actually is to recover it. And that is the conclusion of this. Have a great matrix day.